Hello, it's Mr. Fiedler. I'm going to do a little lesson today, but I want to thank everybody who's contacted me to say that they missed the learning target, right? So for those of you that have said, we appreciate your lessons, Mr. F, but we don't, without the learning target, we don't know exactly how the lesson's supposed to proceed. So thank you for reaching out to me. So today, the learning target, here's what we're going to do. By the end of the lesson, you're going to know what vapor pressure is and how it works, and then you're going to be able to relate vapor pressure with the town, with the city in Quebec. This is the city, and I don't pronounce it properly. I'm going to say it's Lac Mégantic, maybe? The city in Quebec and oil pipelines. So the learning target today, what does vapor pressure have to do with Lac Mégantic and oil pipelines? Okay, so vapor pressure. Vapor pressure is, ready, wait for it, the pressure of the vapor. Let me say that again. Vapor pressure is the pressure of the vapor. And it's the pressure of a vapor of a liquid inside a closed container. Okay, so what does that mean exactly? It means that here's a liquid in a closed container. Okay? At any temperature, including 0 degrees Celsius, there's some amount of this liquid. There's a certain number of molecules that have enough energy to break free of the liquid, float up into the airspace above it here, right? Sometimes they'll land on the walls of the container. And this, at any given temperature, it reaches an equilibrium, right? So there's some particles, there's some molecules that break free as a gas, they float up, and some float back down. Okay, so that's a vapor pressure, the pressure of the vapor above the liquid. Okay, vapor pressure. Now, here's a picture of the same liquid, hot and cold. Let's pretend it's water, okay? So I have my jug here of water. If it's cold, if the water is cold, then not many particles have enough energy to break free. So there's very little vapor above the water. If there's a small amount of particles, you know from this gases unit that the particles hitting the wall of the container is what makes the pressure. So if there's a small amount of particles, then there's not much vapor pressure. So when liquids are cold, we have low vapor pressure. If we heat up the liquid, then there's a lot more energy, a lot more movement, a lot more particles can then break free. There's a lot more vapor particles now above the water, and with more particles we have higher pressure. So the relationship then is that cold water has low vapor pressure, not much vapor. High temperature has a lot of vapor pressure, high vapor pressure. So, what does this mean? Liquids that boil easy. Liquids that boil easy have more vapor above them, right? They boil easy, so it doesn't take much energy to get the vapor above the liquid. So they have more vapor above the liquid, like gasoline, right? When you go into your garage and it stinks like gas, why is that? You didn't spill it, right? It's because gasoline has a high vapor pressure. It means at any given temperature, there's a lot of the liquid that's released as vapor. It has a high vapor pressure. Gasoline boils easy. So gasoline boils easy. It means it has more vapor above, it has high vapor pressure, and these liquids are called volatile. And a volatile liquid means there's always a lot of vapor even at low temperature. Now, if the vapor is flammable, like gasoline, then these volatile liquids can be dangerous, can be explosive, right? Because there's a lot of vapor in the air. Here's a graph, not quite filled in yet. Vapor pressure versus temperature, right? So we said before that if we're at a cold temperature, we have low vapor pressure. Not much vapor is above the liquid. So if you notice here, I have 0 degrees Celsius down here on the X and 0 atmospheres. Atmosphere is a unit of pressure, right? So we'll start at low vapor pressure at low temperature, okay? As we increase the temperature, particles have energy, more vapor is released out of the liquid phase. We get higher and higher vapor pressure, and it goes up, 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 up like this, right? So at higher temperature, higher vapor pressure. Now notice where I had this meet. 100 degrees Celsius and 1 atmosphere pressure. What liquid boils at 100 degrees Celsius at sea level? Seriously, water. Water boils at 100 degrees Celsius. So if we notice, when the vapor pressure of the liquid matches the atmospheric pressure, that's the boiling point, right? Let's make sure that makes sense. The atmosphere is our container, okay? The atmosphere. So, if I take the cap off of this, okay? Now, the atmosphere is pushing down, right? Pushing down, holding this as a liquid. If I heat it up, heat it up, heat it up, heat it up, I have higher and higher and higher vapor pressure, right? When the pressure of the vapor now is high, is the same as the atmosphere can't hold it in as a liquid anymore, and it's free to boil. So the true definition of a liquid's boiling point then is where the vapor pressure matches the atmospheric pressure. Oh, gasoline! Okay, I brushed my teeth. Ugh, don't drink gas. Now, back to the learning target. What does this town in Quebec have to do with it? And I am not telling you what happened. You people need to look it up. What happened in this town, I can't pronounce it. This town in Quebec. What happened in this town in Quebec? And what does that have to do with oil pipelines? Look it up now, then we'll talk about it. So why did I show you those pictures of that Lac-Mégantic rail disaster, right? Key to that rail disaster was that the oil, the crude oil in the tanker cars, very high vapor pressure oil. The oil that comes from North Dakota, right? Very high vapor pressure. So they had the derailment. Now there's a lot of was it safety? Was it derailment? How did the crew? Were the cars new? Were the cars old? There's all that debate about that terrible accident. But the point I wanted to make is that the vapor pressure of the oil was very high, right? So the oil is in these rail cars, and there's all this vapor and vapor and vapor. It's trying to get out, and the vapor is above the liquid in the rail car. And so if you do have the derailment, the car gets blown open, there's some sparks, and boom, right? High vapor pressure, right? And so what you can see there is that it's important that if you have a volatile liquid that's flammable, like, store it properly, okay? Store it properly. Don't be transporting this stuff in your car. It's very dangerous, right? You can see what happens if you have a high vapor pressure, volatile, flammable liquid, right, stored in a container, and it breaks, or there's a